Hello, everyone. Welcome to Pittsburgh Java User Group. I'm Sirisha Pratha. I've got Renat here as well. Renat, do your thing. Yeah. So you can, I guess like you all know already about our meetup website. That's where we post all our upcoming events. And in general, that is where all our registrations go through as well. We do have a Twitter account. If you can follow us there for just general Java updates. We try to, retweet like other Java posts, other Jug meetups that are happening around the world. So yeah, that's that. And all of our recordings from 2021, 2022, and 2023 are up on the Pittsburgh Java User Group YouTube channel. Do subscribe to it so you get the notification to as soon as our video is up each month. For our May session, we do have a very interesting topic on PIT mutation testing. There isn't a lot of videos already available on this subject, so it's going to be interesting to have this covered in our Jug. And we would like to thank our official sponsor, JFrog. Yay! And with that, Grace, I'll hand it off to you. Please introduce yourself and you can take it from there. I think I took a little bit longer than a minute this time.
You're good. Perfect. Thanks so much. It's great to join you all. I'm unfortunately a different time to normal, so I do apologize for that. But I am based in the UK, so it is now 10 p.m. here, so just a little bit behind you guys. So yeah, brought it forward for an hour. So thank you guys for being so accommodating of that. I really appreciate it. So yeah, my name is Grace Jansen and I'm a developer advocate at IBM based in the UK, if it wasn't already obvious from my accent. I actually work a bit with Harry, so that's how I know Harry, so thanks for joining, Harry. And yeah, I've been there for 5 years now, but before that I was actually doing a biology degree at university, so I've taken a bit of a weird route into tech, but as a developer advocate I now do this sort of thing like presenting. I also do coding, a bit of coding, tutorials, demos. I do some article writing, blogging. So it's really a mixture of things that I'm involved with, but mostly focusing on cloud native Java. And so that's kind of where we're going to head to with this presentation, is looking at developer tooling that we can make use of to really enable effective cloud native development. So bringing the cloud back down to earth for us as developers to utilize when it comes to actually developing those applications. So my Twitter handle's on this slide. It will also be on a couple of the others, like the last slide, I think. So if you want to follow me on there or ask a question that I don't get around to today, feel free to reach out to me on either Twitter or LinkedIn, either one. I'm rarely, I usually reply to messages on both. So with that, I'm going to get started, but feel free to interrupt me with any questions or post them in the chat, which I will get up now just to make sure that I can see. Cool. So the first question we want to ask in this sort of topic is why we're bothering with trying to be effective cloud native developers. Why do we want to aim for our applications to be effective in that infrastructure? And really, to me, I think it boils down to this. Now, hopefully you guys are Disney fans, and hopefully you know this movie. If you don't, go and watch Toy Story. It is an amazing movie. I'm a massive Disney fan. It is this excitement that we get, this, ooh, the cloud. As developers, we're excited to be developing for the cloud because it introduces so many behaviors and characteristics and abilities and innovation that we just wouldn't be able to access otherwise. Flexibility, portability, new innovations, for example, like serverless, being able to make use of all of this in our applications is exciting to us as developers. However, when it comes to actually developing for the cloud, it doesn't always end up like this. In fact, if you're like me and you're impatient, usually it's a bit more like this, where you just get super frustrated because it just won't work and it's just not going your way and there's a bug somewhere. And if you're a little bit less dramatic, it's probably a bit more like this. It's a bit frustrating when developing for the cloud, especially when we're developing in an environment that's local, that is so different to the cloud environment that we're putting our applications into for production. So this is why it's important that we utilize the tools that are out there that are available and being developed to be able to bring that cloud back down and really effectively develop in that environment, or as close to it as we can get. And to do that, we have to look at the various different stages of a developer and what a developer's responsibilities are in order to understand which tools are best suited for each of those particular tasks and responsibilities. So what are we trying to do as developers? Well, these are some of the sort of roles and responsibilities that developers are now in charge of. And this is ever expanding as we sort of blur the lines between development, operation, security. Our roles are increasing and our responsibilities are too. So this list is growing, but essentially the basics are we're creating something, usually an application. We're usually adding or editing some code somewhere. Usually we have to build it somehow and then test it, because we're obviously best practice developers and we test everything we do. So definitely testing and obviously writing those tests, repeating that cycle again and again. And often it involves some kind of deployment, especially if we're in a DevOps sort of, again, those blurred lines, a DevOps team. So putting this into a more sort of easier to picture manner, for better words of it, essentially what I've done is make a diagram of this. So this is a diagram that's used again and again and again. But essentially, this is the life of a developer. This is what we do day to day. So it's this ever repeating cycle where we're creating, we're building, we're editing, we're testing. We might recreate something or go ahead and start editing that code. And at some point, we're going to be deploying that into some environment somewhere. And usually all of this is happening within an IDE or editor. So with this sort of development cycle in mind, how do we utilize the right tooling, or maybe not right is the right word, but sort of effective tooling that we might consider using for each of these stages? So I'm going to go through each one and take a look. In terms of the how, there are usually two ways in which people view utilizing cloud native tools. One of them is this sort of beam me up, Scotty, like take me up to the cloud. I want to be in it when I develop. And although that can be effective in terms of meaning that you're in the same environment, it can be slow because you're essentially working outside of your local environment. You're having to have this sort of, essentially everything you do is having to pass through communication layers. You're essentially in this distributed environment now. It's going to take longer. And sometimes tools might not be available, services might not be available. So really, this can sometimes be a very frustrating situation. So instead, what I'm trying to say is maybe we can, instead of beaming ourselves up, maybe we can bring the cloud back down to earth so that we can still develop on our local machines and have that convenience, but we can utilize the tools and libraries and frameworks to be able to gain advantages from that infrastructure that we're deploying into production with. And so for this, we're going to take a look at some various different tools and technologies based on open source Java. And so this includes technologies like, for example, OpenLiberty. So if you've not come across OpenLiberty before, most of the demos are going to be based on this because it's what we work on within IBM here, or at least my team do. So OpenLiberty is essentially a cloud native runtime, which is really designed as a very modular runtime, very lightweight, designed for the cloud and for microservices. And it interoperates with and makes use of various different open source tools and frameworks, including MicroProfile. It's a compatible implementation for MicroProfile. If you've not come across MicroProfile, definitely check it out. It is very much a community-driven specification that enables a lot of very helpful APIs and sort of basically various different cloud native Java APIs to enable effective cloud native microservices based applications. So you can see some of the useful APIs that it offers here. And actually, I'll introduce later on our interactive guides that we have available using OpenLiberty, where you can try out each of these APIs if you want to learn further about any of them. There's also Jakarta EE, another community-driven specification, and the two kind of go hand in hand, MicroProfile and Jakarta EE. In fact, there's a lot of overlap. This bottom line here of the core MicroProfile APIs are actually shared in common by Jakarta EE. So for example, JAX-RS, JSON-B, JSON-P, CDI. So these are actually shared, and actually the same community members often work on both of these specifications. And Jakarta EE is essentially the sort of iteration or the future of Java EE. It was open sourced, And that is now sort of, again, offering various different APIs to help with your enterprise Java applications on the open source side. So with these in mind, let's go through each of these stages or phases in that development cycle and take a look at how we can interoperate with these specifications and tools like OpenLiberty to be able to have effective tools for developing cloud native applications, bringing that cloud back down to earth. So we'll start with the create phase. So in this phase, I'm assuming that most people who are attending a JUG have made a project before. So I'm going to go through this fairly quickly because I'd say the more interesting stuff for you guys is probably later on in this presentation in the later phases. But in terms of creating, often when you've made a project time and time again, especially as an experienced developer, often you view this step as easy. I can confirm it's not easy when you don't know what you're doing. So if you have junior developers or new interns or graduates who are coming in who've never used this kind of technology before, these tools can be extremely helpful in getting them up and running much faster than just trying to create a project from scratch. So starter projects can be a fantastic way to do that. You can get templates from the various different open source specifications or from the runtime specifically. So for an example, we have the MicroProfile starter project here. You can either use it directly from the website, so startmicroprofile.io, or there's actually really useful plugins for some of our favorite IDEs. Now, I have deliberately tried very hard in this presentation to include multiple different IDEs because we are a very opinionated bunch as developers, and I know that one IDE will be the complete opposite of the favorite of yours. So hopefully I've covered you in one of the demos in this presentation. But for this particular starter project, it's just in VS Code and IntelliJ. So if you're using one of those, then maybe consider the extensions or plugins in those to be able to use a starter project. Gets you started with a project like the bare bones of what you need for an application in about 5 minutes. It's just drop down menus, selecting what versions you want to use, what build tool, Maven or Gradle, for example, your group ID, artifact ID, what Java SE version you're using, and also what runtime you want to use. So you'll need a compatible runtime for this particular project. There's also a similar project for Jakarta EE. So if you already know that you want to use Jakarta EE, but you don't necessarily know what runtime you want to play around, then you can use this starter project to get started quickly with each of those runtimes. And as I mentioned, there's also runtime specific starter projects. So if you already know the runtime, maybe it's OpenLiberty, then you can go and check out the OpenLiberty starter. There's also starter projects for things like Quarkus, Helidon, whichever one you want to use. And in these, again, just simple drop-down menus. For these two, you'll need to use the website. There's no plugins yet for those. I think, yeah, I'm pretty sure there's not for OpenLiberty, but I'll double check that one after. But definitely not for Jakarta EE, but these are the websites that you can use, very similar process. So that's a really quick and easy way that we can use tools to get started much faster, especially for our newer hires in terms of creating projects. The next phase is the build phase. And in this, we're really looking at trying to make it efficient in terms of how we're able to see how our code is changing over time. We're rebuilding continuously because we're developing in a much more agile manner now and not in a waterfall style. So really, we want our build tools to be sort of mirroring this agile nature. And for that, we can utilize things like dev mode. So dev mode here is a runtime specific feature. So this is an OpenLiberty feature, but there are similar features in other runtimes. You might have heard of, for example, like Quarkus hot reload, very similar functionality. So a lot of the runtimes have their own version of this, but essentially what this does is it really enables you to be able to it monitors your application over time, basically watches your app for changes, and then rebuilds and repackages when needed, it redeploys. So really taking that onerous off the developers and automating that process. So as soon as you make a change to a file and you save that, it's able to notice that change and rebuild and repackage that so that you can immediately see the changes as you make them. So again, a really agile process there. This is the nice thing is that it's offered through Maven or Gradle, because again, you guys might like one a lot more over the other, and that's totally personal choice. So it is offered for both. And it is this sort of continuous ability to be able to test the code we're using, make sure it's working as we intended, and see those changes in real time. So it can be a massive help in making this cycle a lot more efficient instead of having to tear down our entire application and rebuild it every time we want to see a change. Now, if you're not using a tool that has already got a feature like this built into it, there are other options. So for example, there's an open source project called WAD, Watch and Deploy, that's been made by Adam Bean. Very similar functionality in terms of it basically is a tool that watches for any changes that we make in the project, and then it redeploys our applications. So don't worry if you're not using a runtime that already has this inbuilt, you can check out projects like this and perhaps use that within your application to achieve a similar thing. Then we've got the edit stage. So in terms of editing, most of the time we're doing this within an IDE. So it makes sense for us to have sort of IDE integrations, plugins, extensions that can help us to make this editing phase a lot more efficient, quicker, and also better code as well. So for this, really, it's about making sure that you have the best plugins or extensions for your particular project and making sure that you stay up to date with them. So if, for example, you've switched from, I don't know, like Quarkus to OpenLiberty, making sure that you have the OpenLiberty tools as an extension downloaded, making sure you're keeping up to date with that. There's lots of different sort of extensions that you can make use of. So for example, you can see here, I've just searched in the Visual Studio Code marketplace for MicroProfile, and you can see there's lots of different MicroProfile extensions, and it's up to me to pick the best one for the job. But they're available in basically all of the different IDEs that you could want to use. So Eclipse, IntelliJ, VS Code, NetBeans, whatever you're using, there are extensions out there for you. It's about searching for the right ones and finding the ones that are suited for your project. It's really easy to install them as well, especially please give this advice to your new hires, because often they'll just get started because they're excited and they won't know that these exist. So please make sure that you're giving them that advice that, these tools are built to help you in terms of, enabling things like auto completion, enabling you to be able to hover over elements and get a definition of what that particular element means. All of this can help in terms of not just making a more efficient developer, but also making a developer that understands the code better and can write better code. This, for example, is an example of us. We're using the Liberty Tools extension and the MicroProfile starter project in the IDE. So this is where we're not having to go to the website to be able to create a project. We're just choosing from the drop-down menu here, which is inbuilt into the IDE, to create a project within literally what the time it's taken me to speak, a couple of minutes max. I know I can ramble. So in this, really, it's taken, a couple of minutes, and we've already got the building blocks of creating an application with the particular, we've chosen our build tool here is Gradle, so we've got that all set up. We know that we're using Liberty for this. We've got our various different tools set up already. So we've got MicroProfile there. We're using version 4.1. So you can see it's a much easier and quicker way using extensions and plugins and the starter project to get up and running super quickly. So make sure that we're making best use of that. This is another demo. So you can see here, I've switched my IDE. So this time I'm using Eclipse. So any Eclipse lovers out there, hopefully this pleases you. But essentially here, what we're showing is something called the Liberty Config language server. So this is actually part of the Liberty Tools for IDE plugin. And essentially what this allows us to do is it allows us to do things like, for example, completion for Liberty properties, completion for XML configs, variables, values. It also allows us to hover over those particular properties and variables to be able to understand them better. So that's what we're really showing in the video here, is just how helpful it can be in terms of making sure that that code is understandable. Or you can see here, we're starting our server. Yep, default server has been launched. And there you can see our hover over function, where we're actually getting a definition for each of these features that we're using. So if I was a developer coming into a new project, for example, I could very quickly and easily get up to speed of what features are we using, what do they enable, why are we using them, and to understand the application much easier without the need for extensive comments, for example, within my application. So that's a really helpful one as well. In terms of not just understanding, but also getting coding assistance, there are other plugins that we can use for that. So for example, we can use things like language server plugin. So we've got the language server for Eclipse MicroProfile, which is an incubator project at the Eclipse Foundation. And we just love acronyms. So in tech, we just love them so much. So it's actually LSP for MP, because that's so easy to say. But essentially that's what it means. It is essentially, it's a language server project, and it is still under sort of the incubator status, but we're always looking for help with it. So if you want to contribute, we'd love your help with contributing to this. But it provides in-editor language features for MicroProfile API specifically. That's why it's got that in the title. It offers things like that code completion again, snippets for popular APIs, diagnostics or quick fixes when you use an API incorrectly, for example. So again, making sure that we're keeping our code clean. We've got everything that we need if we want to use a particular feature. And this is especially useful in terms of being able to very quickly understand a particular API in MicroProfile. We have a very similar API available, or coding assistant, sorry, available for Jakarta EE, which is the LSP for Jakarta project. Again, another incubator project, similar features, just this time for the Jakarta EE APIs instead of MicroProfile. We've got a brief demo of this. So again, I've switched my IDE again. This is an IntelliJ. So this is kind of showing that language support from MicroProfile. So here you can see we are creating a cafe controller class. Right away, we're going to start to get some warnings coming up to really show us that we're kind of using stuff incorrectly. We're actually doing this using dev mode as well, which you can see at the bottom in our terminal. So there's our quick fix already. We've already had a quick fix in there. We're going to get another quick fix suggested in a minute. So we're using a REST client API here. And then in a minute, what's going to happen is we're going to try and, yeah, here we go. So we don't have the @inject annotation for the CDI bean. So in order to use @inject, we need the CDI bean. And so it suggested already what we need for that. And just by clicking quick fix, we're able to get that immediately. So if I was a new developer coming in, not using MicroProfile before, and I was like, yeah, all I want to do is inject, I might not know that I need a CDI for that. So it basically helps to ensure that I'm writing the best code possible for my project and making sure that it is actually going to work. So it can be really helpful. There's also things like code generators. So this is sort of going beyond just little suggestions and literally creating code from boilerplates. These tools utilize things like open API tools. So we've got things like the MicroProfile REST client, which essentially it can make a MicroProfile REST client from open API documentation. You can do it either in the CLI, or there are also extensions. In this case, it's in Visual Studio Code. And essentially what this allows us to do is, just generate a MicroProfile REST client directly into our project without actually having to go ahead and create that code ourselves. We can also generate JAX-RS stubs with open API tools too. So I've got a brief example of that here. So this is again in IntelliJ, and we're going to be utilizing that MicroProfile REST client generator to be able to create a MicroProfile REST client. So the aim is to really create it and connect it to our REST service using this generator. It's going to prompt us to use an open API file, which we can see here. So we're just going to pass it the open API document from the REST service that we have already, which is our hello controller. Then we're just going to click generate when it comes up. There we are. So generate REST client into this package. And then we just need to verify the package name that we want it to use. This will create a whole REST client interface based off of that open API document. So if we go into it, we get the APIs folder and then the models folder. In the models, that models folder was generated to work with the drink object based off the drink schema in that open API document. So you can see we've got drink there, we've got costs and stuff, and you can see it's actually come directly from this schema here that was in that open API document. We also, in this models folder, in this APIs folder, sorry, we get some exception classes and the default API class, which is the bulk of basically what we need to get this working. This is basically a whole REST client interface. We can see it has all the endpoints with the right post and get annotations from our REST service, which we've got here. And then all we need to do is basically to make use of this default API class in order to control our REST service. We're going to add a base URI that we're going to want to use for this. So we're going to point it at the URI of the REST service for this particular app. So we're just going to put this in here so that we can actually connect them up together. And we can just get that from the open API document, pop that in, and then we should be able, you can see that my app is automatically updating. So this is really using that dev mode, that agile nature. And then you can see in hopefully not too long a time, yep, the source compilation was successful. So now we should be able to use that in our project. So it really is that simple to be able to get a whole REST client up and running just from that REST service initially and that sort of open API document. So another really helpful code generator tool that we could use. The next stage is testing. So in terms of testing, we obviously have the usual suspects that you're probably already making use of. We've got JUnit, we've got Aquilion, but what tools do we have out there for more automated testing in a way that is more similar to our production environments? If we take a look at methodologies like, for example, the 12-factor or 15-factor app methodology, in those, they talk about the importance of dev, prod, or just environmental parity. So having this similarity between the different environments that we're using, whether that be development, testing, QA, DevSecOps, whatever it is, production, the fact is that we need to have them to be as similar as possible to try and mitigate the risk that we miss errors that might occur in production because we're using a different tool or a different backing service that we don't see in development. So we really need those environments to be as similar as possible. So when it comes to testing, it makes sense that we want to be, again, as similar as possible, using the same tools, putting it in the same kind of environment that we'd be expected to in production. So to do that, usually what that means is when we're running our applications in production, especially in the cloud, normally we're leveraging containers. So it makes sense that we should be leveraging containers in our testing. And we can do that by utilizing some of the newer frameworks like test containers or microshed testing. Microshed testing is just an implementation of the test containers framework. So this is really about stopping that saying of like, well, it works on my machine. No, it needs to work on all machines because we're deploying it to the cloud. So this really enables you to have that similarity and more confidence that the code should work because you're mimicking that production-like environment. The way that test containers works is essentially, it makes a wide variety of testing easier, really looking at things like data access in terms of integration tests, application integration tests, UI acceptance tests. And the way it works is essentially putting it into a container and being able to connect it to other containers that have things like backing services, mimicking what you'd have in reality in production. There are some fantastic benefits of this, obviously. For example, you don't have to fresh instance of a browser, no browser state plugin variations, video recording of your test session or a just failed test session, and being able to lift and shift that exact container to be able to replicate that error on multiple machines if you're struggling to solve that problem. It allows you to test your apps in the same way they would run in production, and there are lots of different compatible implementations. So if you're not using Liberty, if you're using Wildfly or Pyara or Tomee, they are also compatible implementations that you can make use of with this. So to give an example here, so this is our Open Liberty website, and on here we've got loads of different free guides that allow you to get interactive with many of these technologies, like the MicroProfile and Cloud Technologies specs that I showed you earlier. This particular one is using microshed testing. Now, for most of our guides on our website, 90%, I would say, you can actually use the run in cloud feature, which allows you to use a browser instead of having to have all the prerequisites downloaded. You can just go into a browser and run it all through a browser. We have an IDE that's kind of based off Thea that's set up in there. It's got a terminal, it's got the instructions. So it makes it very easy, especially if you've got a restricted laptop, to be able to get up and running with these guides. But for just now, just so I can show you guys the IDEs, I'm doing it locally. So this is in Visual Studio Code. And essentially we are, in fact, I'm going to skip the first minute because that's basically what I've just told you. So I'm going to go about a minute in. Perfect. So here, essentially what I've done is I've cloned the repo. And now I'm going to, where am I up to? Perfect. So I'm running in dev mode, which you can see here. Yeah, I've highlighted it. So I'm utilizing that sort of hot reload function again. So what I'm going to begin doing, perfect. So when we're in dev mode, to be able to run tests, we need to hit enter. And that's just because we didn't want to make it annoying so that it was running tests every time you saved a file, because that can get kind of annoying at times. So we've made it so that it's a deliberate, you want to run the tests. So you can see here, we've got one test at the moment. It's not using test containers. It's just a generic JUnit test. And it's actually inside our person service IT class. So you can see here it is. And if you actually look at the test code, it's just void. So it doesn't really do much right now. But what we're going to do is we're going to try and essentially begin bootstrapping. We're going to import the microshed test annotation. You can see it here in our test. And we're going to annotate that with that annotation so that we can utilize microshed testing. And that essentially indicates to the test class that we want to use it. So the person service IT class basically outlines some basic information that informs how the microshed test starts the application runtime and at which URL path the application is available. Because we're using dev mode, it's automatically updated. And now what you can see when we do the test is it's starting one container. So now we're already using a container. Okay, our test's not doing much, but at least we're running it in a container. So now the next thing we need to do is really look at how we kind of create the ability to be able to use this test. Microshed testing is a black box fashion. So it means that we can't access the application internals. Instead, the application is exercised from the outside, usually with HTTP requests. So to simplify this, a REST client is essentially injected into the tests to be able to poke them and actually make it work to test the application. So that's what we're doing here. You can see we've added the REST client annotation. So now that we've got that set up, we should be able to hit enter again, run our tests. And now, as well as seeing that one container started, what we'll also see here is, building REST client for that class person service. So you can see we are building that REST client to be able to test that application using HTTP interactions. So now that we've got the basic setup complete, we can now actually write our first test case because we haven't really done much testing except that void stuff. So what we're going to do is start by testing this basic create person use case for our REST-based application. So as you can see, I'm literally just trying to create a person called Hank, who's 42. So now that we've written the test logic, we'll now go back, enter again, and see what happens. The good thing is, hopefully, we'll see that it passes. Yeah, perfect. So we're still passing. So we've been able to successfully create Hank. So that functionality is working. But we can't just leave it at one test. That doesn't really test much in our application except one function. So we're going to add loads more tests now. This is much more representative of what we're actually doing in production. So here we're just adding 6 more tests to add, essentially just testing more of the functionality, like whether we can get a person, whether we can return a person. So now we're going to press enter again. Again, we've dynamically updated this class based on dev mode. And now we have 6 tests that run and 6 tests that run successfully. So you can see just in that 2-minute clip, how I was able to take a very, very basic JUnit test and go all the way through to using test containers and implementing that with multiple different tests running in the same container to be able to show you just how quickly it can be done. The next stage in this guide, which I don't show in this video, is what happens if you have different environmental variables that you need for different tests. You can't run them all in the same container. And that's where you need to be starting up multiple different containers for different test classes using that annotation and those variables for different environmental conditions for your test container. So that's the next stage of the guide. So if you are interested, then check out the guide on our website and you can do that second phase, looking at building different containers, which you can have running in parallel for the different apps or different classes, sorry. So that's the testing. So it can be really easy to get up and running with this open source framework for using more production-like environment, bringing that cloud back down to your local machine to test effectively. Then we have the deploy phase, and this is where things get even more interesting. So what about deployment? And this is more around that sort of move that I talked about to moving more towards a DevOps style type of team. And we can use lots of different tools for this. Some of the newer ones include things like build packs, for example. Build packs are really it was a project that was initially created by Pivotal and Heroku, who are the creators of the 12-factor app methodology. They kind of created this project to unify the build pack ecosystem with a platform to build pack contract. So something that's really well defined and that incorporates all of the learnings they had from their various different projects. It is really all about embracing modern container standards, like things like the OCI image format, taking advantage of the latest capabilities like cross-repository blob mounting and image layer rebasing on things like Docker API v2 registries. The basics of it is that it allows you to transform your application source code into container images that can run on any cloud and avoid the need to manage things like Docker files. You do not need Docker files. All you need is your source code and essentially the pack CLI, the build pack specification, and then the pack CLI will essentially put all those bits and pieces together to all of the different layers of the images that you need to create that production ready image that can be lifted and shifted on to run on any cloud. So it can be a really effective way of deploying your applications effectively and having that flexibility and portability that we want in the cloud. In terms of a feature comparison, just so you can see how this compares with other sort of alternatives that are out there, things like having a Docker file or utilizing things like OpenShift source to image capabilities. The advantages with build packs, especially I would say, is things like the advanced caching that it offers. So it offers this built-in caching to improve performance. So you can very quickly rebuild your application, but updating only the layers that have changed instead of having to update everything. Another one is bill of materials. Security is becoming ever more important. So being able to have a built-in software bill of materials or an SBOM really helps to provide insight into the content of your application image and if you have any security vulnerabilities there. Things like reproducibility, auto detection, rebasing, all of these are sort of advantages that aren't necessarily offered by competitors. But this is actually available on the BuildPacks website. So if you want to take a closer look, in case you're using an alternative and you want to see the difference, then the link is at the bottom of the slide here. A way to implement it is to actually use something called Paquito build packs. So this is an implementation of that cloud native build pack interface specification. And it's actually available in multiple languages. So if you're not a Java developer, or maybe you're a Java developer, but your other teams that you work with aren't, it is a polyglot tool. So check out the other languages that are available as well. This is essentially, as I said, it's an implementation. Some of the languages include Go, Node.js, Java, Ruby, .NET. So lots of different sort of platforms on which you can use it. There is actually a Paquito Liberty build pack. So essentially what happens is different runtimes will create their own build pack. And what that allows you to do is provide the runtime or the cloud native runtime. So in this case, it provides Open Liberty to a workflow that produces an OCI image that can run just about anywhere. So the way that you use it is actually quite simple. So this is all you need to do to be able to get started using the Liberty Paquito build pack. Essentially, you've got the first stage is obviously cloning the repo, going into our finished directory. I should note that each of our guides have two different folders. One is start, one is finish. Start is where you start at and then follow all the instructions to get to the end and learn everything. Finish is essentially what you should have at the end of all the instructions. So in this case, we're just skipping straight to finish just so that we have the finished thing. We have something here called the default builder. So we're setting a default builder. A builder is essentially an image that contains all of the components necessary to execute a build. So a builder is an image that contains normally 3 components. One is a set of build packs, which essentially provide your app's dependencies. The second is a stack, which provides the OS layer for your app image. And the third is the CNB lifecycle, which puts everything together to produce your final app image. We're using the base builder in this case. There are different builders you can make use of, and you can head to the Paquito build packs website to check out what kind of builders you might want to use. And then the next thing is just this command pack build. And this is essentially, we're just selecting a few environmental variables here. Like, for example, we want to use OpenJ9. But the nice thing is we're not actually having to specify much else. And actually, there's not much needed within the code itself. So here's a very quick example just to show you how quickly we can get this building with Paquito. So you can see that in our application, we don't currently have any config specifically for Paquito. This is a very simple application, I should note. Basically, all we're doing is just getting our system properties. So there's not really all that much going on. It's just a demo app just to show you guys how this works. So if we go back and take a look at our pom.xml, you can see we don't actually have anything specifically in there for the Paquito stuff or anything we need for it. All we're specifying in our command line is those environmental variables I showed earlier. And so, for example, that we want to use things like the OpenJ9 build pack. We're not having to specify the Liberty build pack or anything because it automatically picks that up from our directory structure. So in app, we have a Liberty directory with our server.xml in it. Paquito basically wants to know to use Liberty runtime in this case. So you can see that here under Liberty config, and there's our server.xml where we're basically saying, yeah, we want to use Liberty as our runtime. So what Paquito will then do is it will go down and essentially pull all the individual images and output a production ready image. So the nice thing is no configuration needed. We just point out our source code. So now once we've got all of these images running, which can take a little bit of time, you can see the various images it's trying to pull. So for example, there's the base builder. Perfect. It's getting there. Cool. You can see that it's reusing some layers that I clearly built earlier. So we've got some cache layers here. So that's what I mean about using that cache to really make this effective and efficient. Perfect. So now we've got that up and running. We can now run the application. So we should be able to see that our application has started after we've used this Docker run command. Cool. So what we're going to do is just check that that's up and running before we try and hit our endpoint. Yep, started 6 seconds ago. Perfect. So now we're going to go, we should be able to see our system properties of the app, of the container that the app is running in, because that's all our application really does, is just collect those system properties. And just, there we go. And just in that short period of time, we'd be able to take a Java application, build it with a runtime, got the JVM, built into a container image, and deployed it to Docker in that really short space of time, using Piquito build packs without the need for a Docker file, because that takes a lot of maintenance, and without the need to have any specific configuration in our application. So a really cool tool to take a look at. Next is telepresence. Again, another really interesting and sort of newer tool that I thought would be interesting to cover here. And yeah, just I find quite interesting, especially given its sort of newness. So this is really about fast local development for Kubernetes and OpenShift microservices. So the key thing about this is that, again, this is all about bringing the cloud back down. Telepresence allows you to swap a pod running in Kubernetes with a service running locally. So all requests to the pod in Kubernetes are redirected to the local URL and port. So it really is basically placing your local machine in that cloud environment without actually having to be in the cloud, which is pretty cool. This is actually a sandbox project from the Cloud Native Computing Foundation. So it's still kind of under development, but it does allow sort of an acceleration of that inner dev loop. It really shifts our testing less and allows you to use your existing workflow without actually changing anything within your application or your workflow. It's a really easy tool to get up and running. You can see the command here that we're using in my sort of terminal that I've got on the left-hand side here. So all we're doing is we're saying telepresence swap deployment, hello world, and giving it the port that we want to use. It's that easy. There's a couple of examples here that I've linked to, one from an old colleague of mine, Sebastian, and another from another colleague of mine, Nicholas, looking at how we can make use of telepresence with applications. The way that it works, so if you want to check them out, do head to those links after. The way that it works is essentially it consists of two core architecture components. You've got the client side telepresence binary, and then you've got the Kubernetes side, which is a sort of traffic manager and traffic agent. So we've got two commands that are needed. The first is the telepresence connect. What that does is it utilizes the traffic manager to establish a two-way proxy tunnel between your local development machine and the cluster. So that means that once you use that command, you can now access remote Kubernetes service as if they were running locally. The second thing is that telepresence intercept service name. So this triggers that traffic manager to install a traffic agent proxy container that essentially runs within the pods associated with the target services. So it allows you to route any remote traffic to your local dev machine for development and testing. So again, a really awesome way of bringing the cloud back down to our local machines without having to do too much editing or work or changes to our workflow. Being able to really get into the cloud and test any sort of services that we might want to utilize or depend on other services, but that we only want to make changes to that one service, for example. So a really cool tool to try out. So speaking of trying them out, as I mentioned, a lot of these tools are available in guides that we have online. So if you did want to check them out, then if you just want to head over to openliberty.io/guides, you can find many of the guides that these demos were based on. We cover a wide range of topics, which you can see in the sort of menu on the left-hand side here. And sort of many of the ones I was looking at, many of the demos I did today are based on those guides. As I mentioned, if you can't do them locally or you don't want to, you don't have to. You can use the running cloud service, which gets you the interactive cloud native labs that we've created. And in this, you get this, it's called Skills Network Labs. That's what we've named it. You get this Thea style IDE. You get terminals and you get the instructions on the left-hand side where we provide all of the code that you need to utilize to be able to follow those instructions and reach the end goal of learning how to use that particular specification or API. So it's a really cool way of just getting stuck in, hands-on, trying it out without having to download anything onto your local machine. So I've whizzed through all of that, but hopefully you found at least one tool that was interesting that you might want to pick up and take a look at. To give you a summary, here is sort of basically a diagram that shows all of the different tools that I've kind of pointed out today, where they sit in terms of whether they can be used with any microprofile, NDT application or whether they're runtime specific. And remember, a lot of these runtime specifics are sort of repeated or duplicated across the various different runtimes that are available. So you'll often find a feature that is similar or does the same thing if you're not using the Liberty runtime in other runtimes as well. But taking a look at some of these, right from the very start where we're trying to create code all the way through to testing and deployment, following that build cycle that we looked at, that developer cycle right at the very start. And as if I haven't given you enough links throughout this presentation, because everyone loves homework, I've got more resource links here. I have labeled them, so hopefully if there was something that piqued your interest, you should be able to very quickly find it in either resource link slide number 1 or resource link slide number 2. But I will put these slides up and make them available to you afterwards. So don't panic and feel like you have to manually type these all in. You can just access those afterwards. So with that, I'm going to say thank you so much for joining me after your working day. I really appreciate you spending the time to be here. Hopefully you found it useful, and I think I've got a bit of time for questions. Thanks very much.
Thank you, Grace. That was a great summary of all the different tools that are out there. It would have taken us years to get to to just figure out all that stuff. So that was really helpful. Very, very helpful. And I see Philip is clapping. Yeah, that was great.
Oh, thanks for the claps, guys.
So were you going to give us a link or something that we can access your slides? I can put that as a comment on the meetup page.
That would be great. Yeah, I'll put it on. Usually I just put them on SlideShare. So I'll put them up there and then I'll link it to you and then we can share it on the meetup.
Yeah, that was great.
People can access.
Yeah.
I've just stunned everyone into silence. There's no question.
It is actually quite a lot of information.
It is.
And
everyone's just processing, clearly.
Yeah, right.
Writing dubious notes, right.
Philip, you have a question?
Yeah, I'm actually still formulating the question, but I'm very curious about the stage of telepresence. That's extremely interesting to me. I never heard of it before, but I think that I have seen reference to it. I just didn't know what it was. So Thank you for that. But I'm wondering if you have any insight into, are there operations that are running or using telepresence in a production capacity? Fully knowing that it's still in development, but that they kind of have the courage to run it in production. I'm just wondering, in what capacity this thing is being tested, because it's very interesting.
The only applications I've seen that have used it have been sort of demos, example applications. I haven't heard of anyone directly that's using it in production yet. And for the reasons you say, right? It's still a sandbox incubator project. And I think people are still aware that it's still changing. That's why I linked to the 2 examples that were from Sebastian and from my other colleague as well, because they are just sort of demos, examples. They're close to what you might use in production, but I've not actually seen anyone use it in production. Not myself anyway.
I guess when I was interpreting what you were saying about it, it looked like a tool for deployment into production, but not that there was any runtime components that would run in production necessarily. But I don't know, maybe there is. I'm not sure, but it looked like it would be used for the deployment into production, like a workflow tool or something.
So I guess it's, in my head, I see it more as almost like a testing tool, but not actually testing your application features, more testing. For example, if I changed a particular service, let's say I got a staging environment, I could probably use it in my staging environment to be able to swap out a service that's in my remote Kubernetes with that local service that I've changed, to be able to test it in that more production-like environment. But I probably wouldn't use it for the actual production system, because it's still a way of testing what I've done locally, because I wouldn't want someone using my application to be using my local service, if you see what I mean,
right?
Because it swaps that routing. Yeah. So I think it's more for a staging style environment, or even development, depending on where you want to use it or what deployments environments you've got available. But I would say it's less for the actual production system, but I don't know anyone who's using it on a production system without that production environment, if you see what I mean.
Yeah, I got you. Yep.
Yeah, sorry, too many of the same words there. But that's where I see it being used. Hopefully that answered your question.
Yes, thank you.
Cool. But yeah, it's a really cool tool. I want to play around with it more.
It seems like you would need a bunch of different environments and be able to test how the abstractions build, or how it builds separate abstractions. And like I said before, it would be part of a workflow management, and in keeping these different environments separate but still testable, but in a representative fashion. And something that I see time and time again is there is that kind of staging or various environments. They're parallel environments, but they're not all the same, exactly. And there needs to be a way to abstract the management of the flowing of code and deployment into these different environments. But the other thing that I'm really interested in is deploying code to different environments is one thing, but what about the data? It's the data that sits underneath, and like the states that are stored in the data, and how those are representative of what would actually be running in production. I still have not seen the right perfect tool or set of tools to be able to manage that aspect. But from what I see with telepresence thus far, that it's a nice direction for getting the management of these various environments in a way that you can really have faith that what you're going to deploy eventually into production is going to work when you just have the hands-on in the developer environment locally. But all these clustering tools and stuff are getting really complex. I mean, every year the complexity is increasing, and it's the management tools, I think, are going to be the important thing.
I agree. And hopefully, this is, as you say, this is an ever changing environment. And I think as we're getting more into the open source world of collaboration, there are more and more specifications and standards, especially standards that are coming out, that are helping that innovation by creating that one standard that we can all work around. And hopefully, things like, for example, like open telemetry, hopefully things like open telemetry will allow us to be able to gather that data in a standard way and create tools that will help us to be able to manage those workflows better and understand the data and be able to understand our applications more. But I think it's a really exciting area, and I agree. I think we're not perfect. I think it's a long way until we are perfect. It's very complex, and we're just doing our best in terms of creating those tools and understanding our apps better. So yeah, we still got a long way to go.
Yeah, but it's nice to have all the different choices that can suit our different applications and different environments. So that's an exposure, a sneak peek into all these was really great.
Yep. Cool. Thanks.
Yeah. Yeah. I mean, if you don't have any other questions, then we can call it. I know, Grace, it's like 11 o'clock for you. So I'm
definitely getting fed up.
Yeah. So I do want to, let you go, and
like if anyone has questions that they think of later, because I know it's a lot to digest, then please do reach out to me on Twitter, on LinkedIn, any of those. Feel free to ask questions there, or ask for the links, or if I don't include them, or any other things that you want to know. Don't mind people reaching out.
Perfect. Yeah. Thank you so much, Grace, and thank you everyone for joining us today, even with the time change and everything. So that's good. We'll see you all in a month.
Yeah, thank you so much. And we'll try to include the links as a comment on the meetup and in the video when we upload that.
I will probably do it tomorrow because I have to go to bed.
No, please do that. That's fine. Tomorrow works, and sounds good then. Thank you so much, everyone. Yeah. Bye-bye.
Thanks, guys.
Bye. Have a good night, Grace.